Okay, so this is closure properties of integers and polynomials. Again, remember you have natural numbers, whole numbers, integers, rational numbers, irrational numbers, and then everything inside this is a real number. Okay? And so what we're going to do is we're just talking about closure properties. Closure properties just simply means if I apply certain rules, do I stay within that number set? All right? So let me zoom this out real quick. Okay, closure properties, integers, polynomials. All right, so what we're talking about is we're talking about integers and we're talking about polynomials. Okay, and again, the operations. So the ops that we're using are addition, multiplication, subtraction, and division. Now, with each of these, the idea behind it is simply this. It is simply if I have an integer and I add it to an integer, will I get an integer? And that is, yes, that is true. If I have an integer plus another integer, I'm going to get an integer. So again, think of like -1 plus -2. Two integers is going to give me another integer, -3. And this always is the case. Okay? So this is true always. Okay, so that's TA. It's true always. For polynomials, so that would be if I had a polynomial, let's call it 3a squared, and I added that to 2a squared, that would give me 5a squared. So I have a polynomial, which I added to another polynomial, which gave me a polynomial, so this is true, and it's also always, because it stays closed in the polynomial world. It doesn't leave that world. So again, remember last week. So if you go back to week 1, you'll notice I say like if you have sorry, let me back that up real fast. If I say -1 plus -2, it's going to give me -3. Well, nothing left the integers, right? It's all still integers. So that's just the idea here. And this is just a conceptual question overall, okay? So for multiplication, same idea. If I have an integer multiplied by another integer, what I will get is, yet again, another integer, and that is true always. Okay? If for polynomials I had 3a squared, and I multiplied that by 2a squared, I'm going to get 6a to the fourth. And this is also true always. So anytime you're adding or multiplying or even subtracting two integers, okay, you're going to always be closed within that number set, okay, because it doesn't leave the number set. That's simply why. All right, so this is true always as well. Now, in division, if I have x divide y, in some cases I might get in some cases I might still get an integer, z, but in some cases maybe I'll get something x over y that is actually a rational number, okay? Which means if that's rational, then this is going to be true sometimes, so TS. And that applies over here as well to the polynomials. It is true sometimes, okay? Because there are some polynomials that I can divide out and not result in another polynomial. I could result, like, if I have 3a squared divide 2a squared, well, the a squareds are gone, resulting in 3 halves, which is just a rational number, okay? So there's a few things here. This is a very simple idea that I'm showing here, but it's this concept that I want you to guys get down. So last, but just to real quick recap, adding, multiplying, subtracting, these all are always true. So always true, okay, for closure, under closure, okay? And division, let me put that in a different color. Division is sometimes true, okay, for closure properties. So your job with your problem set is really just to pay attention to, is it saying multiplication, division, addition, or subtraction, and then just making sure you're categorizing it appropriately. That's it.